Okay, so the last bit of our discussion on control structures for CS150, and again, we're going to use control structures quite a bit through the remainder of the course, so it's not something we can easily forget, but this will begin in the introduction to them. So today we're going to talk about two of them, the for statement and the go-to statement. And last time we looked at the while loop, and there were different repetition structures for while loop. There were sentinel controlled, flag controlled, counted controlled, and end of file repetition structures. We also saw while's redneck cousin do while. So today we're going to take a look at for loops, go-tos, and provide a synopsis of control structures. So here's a counter controlled while loop. The counter starts at 0 while the counter is less than n. We do some set of commands and then increment the counter. And eventually the counter will become bigger than n and we'll get out of that loop. This will run exactly n times. It does what it says on the 10. And we covered this for the sake of simplicity. And this is a valid way to write a counted loop. But there's a better way to do things. And the better way to do things here is the for loop. So the for loop will have an initial statement, a loop condition, and while it's true, it'll do a set of statements, and then it performs an update statement that's also in the first line of the for loop. So here's an example of a for loop. We start out I is equal to 0, I is less than 10, that's the terminating condition, I plus plus, that's the update condition. And we output I, and so this will count from 0 to 9. And at the end, we output an end line. We can also count backwards, starting at 10 and going down to 0 and using I minus minus, and that will count things down for us. So there's where the plus plus and minus minus really come into play. So for loops are called counted or indexed loop. We have initial statement, the loop condition, and the update statement, and we put them all inside the parents here. Notice again, no semicolon goes at the end. And then the statements that we want to do each time it loops through are enclosed inside the braces. And basically those initial statement, loop condition, and update statements are all called loop control statements. And the other cool thing about for loops is they're pretty easy for nested loops. You can increment I and j as control variables, and it's easier to keep track of where to increment each one. So this would also produce that table of stars that we saw in the last presentation. And it does so in a more succinct manner because we're not having to reinitialize things. They get reinitialized at the beginning of the loop. And last but not least is Goto. And I mentioned Goto because you may see it in some old code. It's not something you really want to do. In fact, the great computer scientist Edgar W. Dijkstra wrote an article, I think 1968, entitled "The Goto Statement Should Be Considered Harmful." And so it's kind of like James Dean here having a smoke. It was cool back in the 60s, but maybe not nowadays. But hey, if you want to fire up a Marlboro and put on a leather jacket and write some go-tos, you're more than welcome to do so. Anyway, here's how the go-to works. And again, I show you this because you may see it in code. And sometimes, hey, if you can't think of a better way to do it, if there's no other way to get it done than to use a go-to, then use a go-to. Working code is better than code that doesn't work. So we would put a label here and then do the statement that we want. And then we would say go to here. The unfortunate thing with this is it doesn't terminate. And so this would just keep printing hello world until we pressed Control C and broke out of the program or stopped the program through the graphical user interface. Again, there's always a better way to do things than Goto. And Dijkstra was right on this. But again, if you're looking at old code, particularly assembly, you're going to see a lot of jumps and things that mimic the go-to. So be aware of what this is and that you may find it when you go through some old code. Okay, so thanks so much for watching. Last but not least, we have to conclude with a little thoughts on the each one of them. Each one has their place, while, for, and do while. And if you can determine in advance exactly how many times you need to do something, for loop is the correct choice. If you don't know or you can't determine in advance the number of repetitions, then use a while loop. If you don't know and can't determine in advance the number of repetitions needed, and you know you're going to do it at least once, then you can use a do while loop. For my classes, you can preface any do while statement with a comment saying hold my beer. And that's it for the control structures. Thanks so much for watching.